Good morning, good afternoon, good evening, whichever time you are watching this video. My name is Kabaso Nicholas, and today I'm going to solve one question in mathematics. So this question I'm going to solve, it's under calculus, and I'm sure all of you who are writing GCE, you are writing grade 12, you have to know how to solve calculus. So calculus comes in paper 1 and in paper 2. So we start. I have a question for you. So the question reads, I find the equation of the normal to the curve y is equal to x to the power 3 minus 3x squared plus 3x minus 6 at the point 2, negative 4. So that's the question we are going to solve. Remember, Nicholas solves. So we are going to start looking at this type of question. You can have a look at this question. If you want, you can pause the video, solve the question, and then come back to the video and verify your answer. Let's begin. We have this equation. I'll write it again to say, so the equation is like y is equal to x to the power 3 minus 3x squared plus 3x minus 6. So they say at the point 2, negative 4. So we begin. So if you look at this type of question, the first thing first, we need to find the gradient of this curve. So we have been given this curve, so we need to find its gradient. And now we're going to find the gradient of this curve. The first thing we're going to find, the derivative of this equation. So we are going to find the derivative of this equation, and once we replace the values which we are given, that's when we are going to find the gradient of that equation. So in calculus, we are using differentiation to find the gradient of any given curve. So in this case, we are going to start, we are going to say dy dx will be equal to. So we are going to differentiate this equation here, which we are given. And remember to say, when we are differentiating any equation, we are following this format of saying, when we have the equation like y is equal to x to the power n. So how do we find the derivative of this of this equation or this function? We say dy dx is equal to. So you get this n, which is the power. You say nx n minus 1. This is the general formula we are going to use for us to do the differentiation. Here we go. So we have 3x. I mean we have x to the power 3. So we say this 3 multiplied by 1 here. So if you find x like this, it has a coefficient of 1. So we say that is 3x to the power 3 minus 1. So this is minus. We say 2 multiplied by 3, that is 6x to the power 2 minus 1, plus we have 3x. So there is a 1 which is invisible here. We say 1 multiplied by 3, that is 3. So we go back to the same. We say if we have this x, this is x raised to the power 1 minus 1. So we have this as x to the power 0. And anything raised to the power 0, we know that it's 1. So there is a 1 here multiplying it by, we are multiplying this one by 3, which is 3. So that is the derivative of 3x. So we have another number which is 6, which is a constant value. So for this number, for any constant, the derivative of a constant is 0. Because if we say this is 6x raised to the power 0. So if we say this is 6x to the power 0, we say 0 multiplied by 6, we're going to get a 0 multiplied by this x, that is 0. So the derivative of any constant value is equal to 0. So if we look at this now, we can proceed with say dy dx will be equal to, so 3x, that is 3 minus 1, it's 2. Then we have minus 6x. Then we have 2 minus 1, that is 1. Then plus 3. So this is the derivative function of this curve. That is its derivative function. So looking at the type of the question which we have, it says that at the point 2 minus 2 comma negative 4. So if we have this, these are the coordinates which we have, and in coordinate geometry we learned that it's written like this, 2 comma y. So which means the first number here is the value of x, and the number at the end is it's y. So in this case, we are going to replace where there is x by 2. So in this case, we have 3x, so that is the gradient. So 3x minus 6x plus 3. So this is the equation which we have. So what we are going to do is we are going to replace where there is x, we are going to put 2. So in this case, we are finding the derivative of this function, and this is what we have found as a derivative of this function, and now we want to find what we call the gradient of of this equation. So we are going to take these coordinates, which is 2 comma negative 4. 2 comma negative 4. So where there is x, we are going to replace it with 2. So I'm going to say 2 to the power 2 minus 6 multiplied by 2 plus 3. So this is what we have. So now that we have this, we can do some multiplication. We can do some operations here. So we are going to say 3 multiplied by, so 2 to the power 2, it's 4. This is 4 minus 6 multiplied by 2 plus 3. So we have this. So 3 by 4, we get what? We are going to get 12 minus 6 multiplied by 2. We're going to get 12 plus 3. So here, 12 minus 12 is 0, plus 3 is 3. So we find that the gradient of this curve is equal to 3. This is the gradient of the curve. So now, what we are looking at is a situation whereby this is the cubic function, for example. So it will look like this. Yeah, so it will look like this, and then let's say we have something like this, something like this. So let's say a point 3, 3 is somewhere here. This is where we have our 3. And then here we have, let's say we have negative 4 somewhere there. So we are looking at this tangent line, this line. So that is the tangent. So this is the point we are looking at. Now, in this case, we have been told to find the equation of the normal. So remember that when we are finding the equation of the tangent, we are going to use this gradient directly. We are not changing anything from this one. Okay, so now what we are going to do is that we are going to find the gradient of the normal curve, the gradient of the normal. I mean the gradient of the normal line to the curve. So if we have this line of this nature, we have this is a tangent, and then the normal line is like this. Yeah, so it's like this. So it makes a 90 degrees with this tangent here. So that is what we are looking at. So now there is a formula which we are going to use to say gradient, which is represented by m, we call this gradient 1, will be equal to 1 over let me just move my book here. Yeah, just move my book here. So this one will be like 1 over negative m. So that is negative of that gradient which we have found here. So we say m1 will be equal to 1 over negative 3. So our gradient for the normal will be equal to 1 over 3, which is negative 1 over 3. So that is the gradient of the normal. So we have this gradient. Now we are going to apply a certain rule. We are going to apply a certain formula. So we know that the straight line has this equation, which is y is equal to mx plus c. Y is equal to mx plus c. So that is the equation, the formula for the equation of a straight line. So now that we have this equation, we need to find these values. We need to find m. We need to find also need to find c. So c is the constant value, or the y-intercept. So that's what we need to find. So in this case, we have been given the coordinates to say there are 2, negative 4. Those are the coordinates which have been given. So we are going to use those coordinates for us to find the value of c, so that we can find the equation of the normal to the curve. So how are we going to do it? So we have already found our gradient to the normal, which is negative 1 over 3. That is the gradient which we have found. That is the gradient of the normal to the curve. So now we need to find the equation. So we have been given the coordinate, which is 2, negative 4. So we have been given these coordinates here, which I've written here, 2, negative 4. So what we are going to do is that we are going to replace these 2 coordinates into this formula, into this equation. So we are going to replace, where there is x, we are going to put 2. Where there is y, we are going to put negative 4. And where there is m, which is the gradient, we are going to replace it with negative 1 over 3. So what you are going to do is that we are going to say negative 4 is equal to, our gradient is negative 1 over 3. Then we say plus x. What is our x? Our x is 2 plus c. So we want to find the value of c. So we say negative 4 is equal to, we have negative 1 over 3 multiplied by 2. We have negative 2 over 3 plus c. Okay, so this is what we have. So we want to find the value of c. We say negative 4. If this negative 2 over 3 crosses the equal sign, it will become positive. So we say 2 plus, plus 2 over 3. That will be equal to c. That will be equal to c. So we are going to evaluate this. We're going to evaluate this, and I'm sure you know how to evaluate such kind of things, whereby we are going to find the common denominator here. And in this case, our common denominator is, 3. So we say 1 divided by 3 multiplied by negative 4, we have negative 12. And then we say plus. So we have 3. 3 into 3 is 1. 1 times 2, that is 2. So what we have here is that we have negative 12 plus 2, that is negative 10 over 3. So this negative 10 over 3 is the value of c. So what we are going to do now, knowing the value of c, and knowing the knowing the gradient of the normal, we are going to find now the equation of the curve, the equation of the normal to the curve. So we are going to use the same equation to say y is equal to mx plus c. So we are saying y is equal to, what is our gradient? Our gradient is equal to negative 1 over 3, then x plus negative 10 over 3. So once we have something like this, we're going to say y is equal to -1 over 3x, positive times negative, we say minus 10 over 3. So you can leave your answer here. It's very much okay. You are going to get full marks. So thank you for watching this video, ladies and gentlemen. See you on my next video.